RISC-V, the open processing architecture that we deserve. So this story came on my radar from this Oregon-based company called AheadComputing, and they are this is a company full of Intel's top chip architects who left the company to attempt to build the biggest, baddest CPU in the world, according to Debbie Marr, the company's CEO. And of course, they're talking about the RISC-V open processor architecture. Now, this was developed in the 80s, more of an educational platform for people and students to learn about processor architecture, but now it's actually becoming used in industry and getting ready to be released to consumers. Now, if you know a little bit about chips, you know that Intel's has an x86 architecture, which runs on most consumer devices like laptops and computers. There's also the ARM architecture, which runs on 99% of mobile phones and also a lot of computers. So these are the two that we use mainly today, and the main difference is that there's this thing called the instruction set architecture, which are the basic commands that software can send to the processor at a foundational level. So this could be things like how to add two numbers together, or how to store something in memory. So the software on your computer needs to be specially written to follow the processor's instruction set architecture, or ISA. And so the main difference between RISC-V and the traditional processor architectures is that RISC-V is open. It's open in that anyone can create a processor based on RISC-V without paying licensing fees or royalties, which makes it way more accessible to chip companies. That's why we're seeing startups like AheadComputing get into the game. Two, that you can make changes to the architecture because it's a modular architecture, it's not monolithic, meaning that there's a base set of instructions and a number of extensions, so you can change it as needed. It can be flexible and tweaked according to whatever processor you want to build. And note that RISC-V, this is not an open source processor, but it sets the stage for an open source processor. What RISC-V is an open specification. It's like a blueprint without licensing. So anyone can make a processor based off this, and it's their decision to whether they want to open source the software for their processor. That's up to them. It's not anything that appeared out of nowhere either. It was developed in 1980 as a research project, and there's been 5 generations of improvement. So they've raised 21.5 million. Here's RISC-V's website talking about their journey, how at first it was made for microcontrollers and embedded systems, and how it's kind of just been improving and evolving, being included in microcontrollers for cars. And then this past year, we actually have seen it being deployed on laptops as well. Deep Computing released the first RISC-V laptop named Roma in 2023, followed by the DC Roma 2 in 2024, which was shipped with Ubuntu pre-installed. So it's really exciting. Now, these are developer laptops you're gonna find because a lot of the software that you use on a day-to-day basis hasn't been ported, that you're not gonna be able to do much on them. But it's still really impressive. An operating system like Ubuntu and everything associated with that is running on a RISC-V laptop. And these laptops are pretty cheap. You'll notice when you get it, if you get it, that they're underpowered. But this is really early on in RISC-V's evolution, and it'll only continue to be improved. And maybe one day we'll have a processor that's cheap, performant, and also open source. That's at least is what I'm praying for. So this is really cool. Here's some other stuff I found. This is a list of all the software that RISC-V that has been ported for RISC-V, and there's a lot of different things here, debugging tools and compilers, and also software languages. So soon we could see more software developed for RISC-V. This is just their evolution. You can see how they went from hardware and just testing chips, and now we're to the point where we're using Linux. We have drivers, and they're also building AI compilers for it.